Dear students, now I'm going to discuss the crystal field splitting of the orbitals in trigonal bipyramidal complexes. Right? So, if you see the trigonal bipyramidal complex geometry, the three ligands are approaching the metal ion. The three equatorial ligands are approaching the metal ion in trigonal planar manner, and these two axial ligands are approaching the metal ion in a linear manner. And this is a trigonal bipyramidal structure. And if we observe the approaching of ligands towards the metal ion, all the ligands are approaching the metal ion along the axis, right? So if you see the splitting, when the metal is in free state, all the 5 degenerate d orbitals are in degenerate state, right? So all the 5 d orbitals are, as we know, dx square y square, dz square, dxy, dyz, dz square, dzx. So therefore, the higher energy level will take place by the dz square orbital, because along the z-axis, two ligands are approaching the metal ion. Therefore, the interaction between the orbitals which are lying along the z-axis, that is dz square, is more with the ligand orbitals. That's why it will get more repulsion. That's why it will get the high energy level. Then the next energy level will takes place by dx square y square and dxy orbitals, because the ligands are approaching the metal ion in xy plane like this, right? And therefore, the lower energy level will take place by the orbitals dyz and dxz. If you see the crystal field splitting of d orbitals in square pyramidal geometry, right? So when the metal is in free state, all the d orbitals in degenerate state like this, and the square pyramidal geometry, the origin is again octahedral. Therefore, the primary splitting is according to the octahedral. The higher energy level will take place by EG and lower energy level will take place by T2G set. And from this, the splitting of d orbitals into various geometries will take place. From EG set, dx square y square dz square orbitals, dx square y square orbital will get the higher energy level, because in xy plane the approaching ligands are 4. Therefore, the dx square y square orbital will get the close interaction and will experience more repulsion. That's why it will get the high excited state, high energy level. And this dz square will get next energy level. And from this 3, dxy, dyz, dzx, dxy will get the higher energy level, and the next energy level will get by dyz, dzx orbitals. If you see the crystal field splitting of d orbitals in linear geometries, right? So if you see the geometry of complex, the two trans ligands are approaching the metal ion along the z-axis, right? So when the metal is in free state, 5 degenerate d orbitals are in degenerate state. Then from this, the splitting of d orbitals will take place. So the higher energy level will take place by, of course, dz square orbital, because two trans ligands are approaching along the z square, right, along the z-axis. Therefore, dz square orbital will get more interaction and experience more repulsion. That's why it will get the higher energy level. And the next energy level will take place by dyz and dxz orbitals. And the lower energy level will take place by dx square y square and dxy orbital.